so lovely beings, on your work, we should have been going through the rational functions. So if you're looking at what we have to cover over here, we're pretty much, we're going through quite nicely, and we're down to, you were doing the deduce the behavior of various functions that are composite, that's fine. We've done this, the graphs of rational functions. If you go through, we've ticked off, oh, you can't see, but we've ticked off basically everything. What we have to do now, you can't see my projection. What we have to do now is just your modulus stuff. So do we recall what modulus is? Have we seen it before? It's a very complicated thing. She says dripping with sarcasm, right? So modulus is basically, oh, why has that done that? Oh, look, I'm going to write this, and you then might go. Yes. So your modulus, if we look at this, this is also referred to as the absolute. Yep. The absolute value / modulus, and Tom has said, what'd you say? Modulus. Magnitude. So you've seen it before when we did vectors, right? You've seen, and it's like if I'm a distance from the door, I'm not -3 meters away, I'm just 3 meters away from the door. It's not left or right. So pretty simply, if I have modulus of -4, that's just going to be 4, right? So simple, it's scary. There are some properties that we're going to look at, and we're going to graph modulus functions as well as mess around algebraically with it. Okay. They're playing around with their pens over there. So we can see here on page 71, this, can I draw on it? You can't see me pointing. The top green box, that's basically what we just talked about. If we take the modulus of a negative number, bang, it becomes positive. Huzzah, huzzah. If we want to graph it, we'll see in a minute how we graph it, but that doesn't. And this little property here is very important too, that to get rid of a modulus sign, you can square it and root the sucker. So I'm going to say, let us not do 3f. Would you agree? 1a, what's the modulus of -2? Oh, 2. Same with 2, it's just subbing in. So we're happy that we're all happy if we get a negative answer, we just take the positive value. Good. The nodding of the heads are good. Question 3, that is just proving this little green box here is true. Okay, so if you're happy, I'm also going to skip 3a. Use this fact to prove part 1 and part 2. Can we do that? Didn't mean to run for that. So, sorry, G, I forgot to record, and Danby and the rest of us, and Karen, and who did I forget? Paul? No. It's back. So right hand, we started with the right hand side rather than the left hand side because that just made sense. So we're just applying this theorem there. Now, they're giving me big looks about, oh, this is very straightforward, and I agree with you. So all of this is basic, and so if you skip all of that, believe it or not, I'm quite happy. 5b, we could probably have a look at. So you could, I'll write it down here, try and see 5b, and if you get stuck, then I'll come and do it with you. But exercise 5b. Try question. What I really want to just quickly go through and to make sure that we're all groovy is question 6. Now, you don't have to write anything down if you don't want to, but if you want to, go forth. Because it's mainly about calculator business that I want to look at here. So we want to graph y equals, I know I'm writing it again, y equals x take 2, and we're going to have 2 situations. We're going to have the graph when x take 2 is greater than or equal to 0, because that is where the modulus has no effect whatsoever. Do we agree? So when x is greater than or equal to 2, in other words, when x is greater than 2, what is your y function? It's when no modulus is affected and it's just going to be x take 2. Do we agree? Yeah? So if the thing inside the modulus is x, so x take 2 is the thing inside the modulus. If that's greater than 0, the modulus signs have no effect on it whatsoever. That's all we're saying. Agreed? So obviously, if now x take 2, the thing inside, is less than 0, aka if x is less than, I should say greater than, yeah. What does that mean is in the modulus there? It is the negative of that modulus. So it could be that it is minus, y equals minus the thing that's inside the modulus. Does that make sense? The whole thing inside is either all positive, so we get this, or it's all negative and we get this little sucker. Agreed? So that means we get this function of y equals minus x plus 2. Yep. So that was minus the whole thing. Again, I'm doing this really quickly because the whole point is I want you to see the calculator. Okay, so if I was to graph, you get this weirdo function, this y, I guess should we do it here, this y x take 2. So y equals x take 2 we know is a straight line and it's got a y-intercept here of minus 2, yes? So it looks a bit like this. Why have I drawn that as a dotted line down there? Because it doesn't actually exist. Because we're saying that only when x is greater than or equal to 2, it's this bit here. Yeah? So technically, I shouldn't have that, but I'm just showing you why it was there. And then we've got, I'll draw it in yellow, even though it should be exactly the same. This bit here is now minus 2. And what does that look like? We know it's growing. It's going the opposite way and it will cut through here at 2. Agreed? Now you're going to go around, you're going to play. You can see there's a whole lot of different functions that you're going to play with. And it's basically this that we go through all the time. I'm happy to do one by one on the board, but I'm getting the looks from you. But what I want to do is, can we graph this on our calculator? Can we? Do we remember where our modulus thing is? So this was the whole point of the lesson. So grab your calculators, I'll wait. All clear, we can actually type in modulus x take 2. So we're going to go option, numerical, and then you can see ABS. So we've got that there and we can just type in x take 2. And have I got it on, let's go standard, yep. And bingo bango bob, we get our, anything that you've noticed about that function. Like what if I now go option, do just the original, option, numeric, absolute, just of x. So that's your red one. Yeah, well, we just did minus 2. Right? And what happened when we did x take 2? It was a to the right by 2. So, Tom, you just said try x plus 2. What do you expect to happen? Yeah. So when we go x plus 2, and these are some of the translations that we've seen similar to quadratics, trig graphs, etc., etc. Yeah. And sorry, just one thing. Have you noticed that mine is drawing simultaneously? Do you know how to do that? So shift menu, I had mine on simultaneous. If I turn it off, then they draw one by one. This is a little something we play with the year 9s. Okay, so a couple of questions coming up. Now, some students were going ahead and asking about stuff like this. What I would like you to do, I mean, I'd like to go through, but I guess you're doing your thing. We come over here, one-to-one functions. I had this. We were looking at just the inverse, whatever, but if you scoot down, we've now got the absolute value. And we can see that we've got a difference between when it's all around the function, the absolute value is all around, or when it is just around the x. So in a nutshell, I mean, you can read, but basically when it's all around, anything that is negative flips and becomes positive. Right? On our calculator, let's have a look at that. So we'll just deselect, deselect. Okay, I'm going down to number 4, and let's pop in x squared, and we want it to go below the x-axis, so let's say take 6. Agree? So we go, yeah, looks nice. If we now apply the modulus function to this, so option, numeric, absolute value, can you see how I get my YRXT? So I can now type in, it's the y function, but where is that function that I want the modulus of? In 4. So I can go the modulus of Y4, and we get the black. Now, as we're saying down here, when we've got the modulus of x here, again, please read what's underneath. So basically, you remove the graph to the left of the y-axis, right? And then you reflect the remaining bit. So you can see, oh, you can't see it on this one. So sorry, listening at home, G and, no, I can. Oh, here we go. So we remove this bit, right? You remove anything that's to the left, and then the bit that's remaining, we reflect in the y-axis. Sky was just asking, how do we do that on our calculator? So again, we come back over to here, and when we've got x squared take 6, well, it's a little bit more of a protracted thing. We go the modulus, modulus of x squared take 6. Oops, that didn't work. I had to put it around the whole thing, didn't I? Oops. So, oops, I had to have the modulus there of x. Right, and now when I draw, still not working. I will fix that. Oops, that's because I didn't put the x to 6x. I'm doing 2 different functions. Anyway, okay, so said Brody's eyes will light up because he asked me last week, can you give me some of the previous templates? So if you look now at revision, we've got a fair bit of stuff for you to do. We've got review solutions of chapter 2. But they're the work solutions. Now, I'm not asking you to do every single question from chapter 2. You will pick some. Like some you'll just go, I'm not wasting my time, I know how to do it. Pick the hard ones, but this is work solutions. Only go to the work solutions if it's a last resort. I would prefer for you to wait, ask me a question. We can go through it and say, well, if you're stuck, what are some of the things that you can do to help you along, rather than, oh, let's just look at solutions, because let's face it, you're not going to have them in a test. You've also got the chapter 3 solutions. Okay, I've shown you on my little thing, there's a revision guide. There's not an awful lot of questions for functions in the revision guide. So there's very sparse, but there's a couple sketching that I do like. So you've got them. You've got a SACE exemplar that they put up on their thing. Theirs is a non-calculator component. Ours is not non-calculator, so have a look. And then, we've got 2 practice tests up there that you can have a look at. Of course, you're not going to get to those until you're fully. So with composition of functions, it actually included sine and cosine. So if you're looking at your, oh dear me, don't want that. If we're looking at our Bible here, I've lost it. Here it is here. Okay, and appropriate domains. So I will give you some more questions that involve those, but remember your sine and cosine can only go between 1 and -1, depending on how they've written. We haven't done a lot of that, so I'd probably say you could probably find composition functions, but maybe I'm not going to ask you for domain of those just yet. We'll do a little bit more trigonometry. Do have a look here. Note that when we're looking at reciprocal functions, 1 over f of x, they could be linear. The function could be linear, it could be quadratic, but it could also be trigonometric. So that's when you've got your 1 over functions. Can you remember what they were from last year? What's 1 over cos? So cotangent, cot is 1 over tan. 1 over sine, we really want, no, 1 over cos, we really want that to be?
Sec.
We really want that to be cosec, don't we? But it's not. It is sec. Whereas 1 over sine is your cosec. That's how I have to remember it. So, you know, again, you've got your graphics calculators, have a little bit of a look. But today, it's just getting stuck in, and then we'll go through more of it tomorrow when we've got our double. That's me out.